In this video, we're taking an in-depth look at processing your 3D capture datasets in Substance 3D Sampler 4.0. Keep in mind, this is a first release. Things will change and improve over time. When doing 3D capture or photogrammetry, most of the effort is in taking good photographs. You might want to watch our dedicated videos on that subject first to guarantee the best results. Also, keep in mind, we've designed and focused the 3D capture experience for objects up to human size. You might run into issues when you use a very large data set, and that means above 6 gigapixels, which is 512 megapixel photos. We'll be using a set of photos of a glazed ceramic pot, which you can download to try out yourself. This dataset is of good quality and guaranteed to work well. If you flip through the photos, you'll see they are high resolution, sharp, and evenly lit. If you zoom in a lot, you might find small focus inconsistencies or see areas that are not perfectly lit. This is usually fine. The process can handle small inconsistencies like this without much trouble. So to get started in Sampler, we create a new project. You'll notice a new 3D object section in the projects window. Click the plus next to that and pick New 3D Object to get started with the 3D capture process in a new dedicated window. Select all your photos in the Explorer and drag them onto the 3D capture window. After loading for a while, your photos are presented in a list and as a gallery with properties for the selection on the right. The photo groups list on the left is based on the camera and lens used for the photos. If you mix photos from multiple devices, like a cell phone, DSLR camera, or a drone, you will get separate groups here. With the group selected, you get an overview of its properties. In this case, the focal length and sensor size are missing. We can fill these out manually if we know the numbers. The camera we used has a 35mm sensor size and the focal length was at 70mm. This info can help improve the processing a bit. Now, the most important option is under the mask section. Because we've taken photos on a turntable, our background did not change much, but our object did. This can cause the alignment process to completely fail. On top of that, our background contains no meaningful info at all. To solve this, we'll want to mask out our subject for each photo. The easiest and best way to do this is to use the automatic batch generation. Select Generate, then New Batch, and wait for Sampler to create the masks. This uses Adobe Sensei Select Subject technology, just like in Photoshop. With 72 photos, this process takes a while to complete, so best to be patient. You can verify an individual mask by selecting a photo and clicking on the eye icon at the bottom right, next to the mask path. This shows a grayscale preview of the mask. If the automatic masking makes a mistake and kept parts of the background, don't worry, a few incorrect masks are not a problem. But the majority of masks should have just your subject. This is why it's key to shoot your photos on a uniform, plain background. It's much easier for the automatic masking to work well. If most of your masks are not correct, you can either fix all of them manually or reshoot your photos with a more suited background. You might want to retry a dataset multiple times, and you want to avoid regenerating your masks each time, as Sampler deletes these once you close the app. Your masks are cached in your documents /Adobe Substance 3D Sampler /3D Capture /P1. If you do multiple assets in a session, you will get folders called P2, P3, etc. It's a good idea to copy the cached masks to a safe location with your dataset, so you can save time if you need to revisit this dataset. With correct masks, you're ready to move on to alignment. Press the blue Submit button in the top right. You'll get two options: precision and photo ordering. Precision can improve the alignment. It's best to start at low, and if you get failed photos, try again with high. Photo ordering relates to the order you shot your photos. If you've walked around an object and shot inspiring circles, you can go for sequence to save some time, but usually default is the safest option, even if it might take slightly longer. Click Process and wait for the alignment to finish. This can take several minutes, so best to be patient again. Once finished, you see a point cloud representation of your object, with each photo represented as a camera floating around it. An orange warning triangle at the top left means some photos have failed to align. Hit Back and try with high quality precision and default ordering if you haven't already. Now, some photos might still fail to align, and this means there's not enough overlap or not enough detail in them. You might have to revisit your photographing process to solve this, or you can just ignore them if it's only a few photos. Looking at your point cloud data, you might see stray points floating around your object that are not meant to be part of it. This is usually due to some bad masking. In this case, a few bad masks have caused it to pick up some dust particles. You can crop these out using the eye icon on the right next to Region of Interest. Simply move the square handles that appear to get a tighter fit around your object. Any points outside of this box, shown in dark gray, will not be included in your final 3D model. You can also use this bounding box to pre-rotate and align your model better. If you look at our pot's point cloud, you can see some areas have much denser points than others. This isn't really a problem. Less points just means that the surface will have less geometric detail. It comes from a lack of detail and contrast in the white clay, while the noisy glaze is much easier to track. There's only one setting left before we create our mesh. Under Geometry Details, you can select the initial geometry detail level. Raw is the undecimated mesh. It's not really recommended to use this unless you're sure you need it. Full to draft are decimated meshes. You would pick lower options to get a test result faster, higher options to get more detail at the expense of slower processing. I know this set works well, so I'll go for full. Hit Submit to start the mesh processing. This process can take a while, even longer than any of the previous steps, so best not to wait around for it. Once your mesh is done, the final window lets us preview and post-process our mesh before we add it to our sampler project. This mode has a few buttons at the bottom to see your mesh with texture, shaded solid, as a wireframe, and with a UV checker material. The post-processing settings on the side let you generate a new version of your mesh. That means a retessellated mesh with new automatic UVs and texture baked from the original mesh. The main controls let you set a target face count and toggle normal, height, and AO baking. There are a lot of advanced settings to tweak. We won't get into those in this video as the defaults usually work fine. Keep in mind, you can also do this mesh processing step afterwards once the mesh is added to sampler. Going by the wireframe, this mesh looks good, so I'll just add it to sampler. Once you give it a proper name, it appears in your projects list. In the next video, we'll dive into editing the mesh and textures a bit. But for now, you can already export your result using the Share, Export As dialog. General settings let you choose name and path. Mesh settings let you choose the 3D mesh format, and material settings let you configure the material of the mesh. You can toggle mesh or material off to export only one of them individually. Once exported, your mesh is ready to use in other 3D applications.